Hello everyone. We have discussed two parts of the lesson carbon and its compounds, which included major subtopics like occurrence of carbon, bonding in carbon, formation of covalent bonds, hydrocarbons, isomerism, and functional groups. Today, let us discuss something more related to the carbon and its compound in the lesson Carbon and its compounds. Today we shall discuss about the chemical properties of carbon compounds. First one is combustion. Carbon compounds burn in oxygen to form water, carbon dioxide, heat, and light. Example: carbon plus oxygen gives us carbon dioxide plus heat plus light. Second property is oxidation. Carbon compounds like alcohols are oxidized to carboxylic acids on heating with oxidizing agents like alkaline potassium permanganate or acidic potassium dichromate. Example: alcohols are oxidized to carboxylic acids. The following is the reaction for the same. Third property is addition reaction. Unsaturated hydrocarbons undergo addition reaction with hydrogen in the presence of nickel or palladium as catalyst to form saturated hydrocarbons. Example: ethene undergoes addition reaction with hydrogen to form ethene in the presence of nickel or palladium catalyst. The following is shown in the reaction. The next property is substitution reaction. Saturated hydrocarbons undergo substitution reaction with halogens to form substitution products. Example: methane undergoes substitution reaction with chlorine in the presence of sunlight to form substitution products. The following reaction is shown. Some important carbon compounds are: first one, ethanol, that is C2H5OH. The properties are: ethanol is a colorless liquid with a pleasant smell and burning taste. It is soluble in water. Ethanol reacts with sodium to form sodium ethoxide and hydrogen. Ethanol reacts with hot concentrated H2SO4 to form ethene and water. Concentrated H2SO4 is a dehydrating agent. The next one is ethanoic acid, that is CH3COOH, acetic acid. Properties are: it is a colorless liquid with a pungent smell and sour taste. It is soluble in water. It showcases the property of esterification. Ethanoic acid reacts with ethanol to form the ester, that is ethyl ethanoate, in the presence of concentrated H2SO4. The next one is saponification. When an ester reacts with any OH solution, sodium salt and alcohol are formed. Next is ethanoic acid. It reacts with bases to form salt and water. Next one, it reacts with carbonates and hydrogen carbonates to form salt, water, and carbon dioxide. Our next subtopic is soaps and detergents. Soaps. Soaps are long chain of sodium or potassium salts of carboxylic acids. Example: C17H35COONA. Structure of soap molecule. A soap molecule has two parts: a long hydrocarbon part, which is hydrophobic and soluble in oil and grease, and a short ionic part which is hydrophilic and insoluble in oil and grease. Cleansing action of soap. When soap is dissolved in water, it forms spherical structures called micelles. In the micelle, the hydrocarbon part is faced towards the center and ionic part is towards outside. Detergents. These are long chain sodium salts of sulfonic acids. Soaps do not wash well with hard water because it forms insoluble precipitates of calcium and magnesium salts in hard water. Detergents wash well with hard water because it does not form insoluble precipitate of calcium and magnesium salts in hard water. So, this was all about the third part of our lesson. And with this, we conclude the lesson Carbon and its compound. Learning about carbon and its compound is important as major components of a daily food have carbohydrates, proteins, fats, etc., which are all made up of carbon compounds. The fibers of clothes are made up of cellulose, and other types of materials are also made up of carbon compounds. Cement and steel form the core of any of the modern buildings. So, learning about this is very important. Thank you, students.